organisms or looking at them. And when they did begin to look at them, they weren't the sophisticated ways that we were looking at them now. Somebody had a hand lens and started looking at the microscopes with just a hand lens. And after the hand lens, then they put one lens on top of another, and that made a compound microscope. So one magnifying glass was a hand lens, two hand lenses was a microscope because it was a compound microscope. One enlarged the size of what they were looking at, and the other enlarged the image. So originally that's what happened. In the 1600s, Janssen came up with the compound microscope, and basically what he did was just hold two lenses on top of each other. Janssen. He was followed, and when we look at the history of micro, there are a lot of years that go by where we don't look at anything. We don't say, oh well, this happened in 1610 and this happened in 1616, because there was no longitudinal historical record. So we see these events and we mark them. There's a timeline in your textbook that shows you some of the things that happened. Well, Janssen was followed by a man by the name of Hoke, Robert Hoke. Robert Hoke started to look at things, but they were dry, whole objects. He looked at cork and he looked at leaves and tried to discern what the structure of these entities were. And that was really the beginning of the use of microscopy. So really, if that's in the late 1600s, we're really only looking at about a 350 or maybe 325-year history of microbiology. And it was dependent on what could be seen. But the one that you remember the most is Van Leeuwenhoek. Remember him? Everybody associates him with microscopy. And the record is really a record from Western Europe. That's where the record was found. Van Leeuwenhoek had an interesting couple of terms. He described the things that he was seeing in using the microscopes as animal fuels. Isn't that funny? An animal fuel. Nobody knew what a cell was, and nobody knew what the entity of what he was seeing really was truly. But he did a lot. He studied urine, he looked at people's urine, he looked at people's saliva, he looked at yeasts. He didn't know it, but he was looking at bacteria, he looked at algae. And the maximum magnification that was available at that time was 300x. They could use those hand lenses to get up to 300x. Today, we study microbacteria at 1,000x. So they were only really seeing a third of the world back then. And interestingly enough, there was no theory of the origin of life at that time. Nobody had any idea how life was supported or how it began. They knew how babies happened, but they knew life in general. So with no origin of life, the theory that came up was called abiogenesis, which essentially said that it is possible for life to come from non-living materials. And that ushered in an era of experimentation that is really quite interesting. This abiogenesis could be interpreted as also spontaneous generation. Spontaneous generation. Now, science develops when people get ideas and then test them. Somebody will get an idea and then perhaps devise a test that will test the idea. And then they'll come up with a conclusion. So when someone gets an idea, that idea is an hypothesis. An idea is an hypothesis. And this is a very weak statement. It's an I think statement. An I think statement. What they will do then is set up a series of what would be considered experiments or conditions to test the I think statement. Based on the results, observation of the results allows people to make a stronger statement, which is a theory. And the theory is an I know statement. It's based on the presentation of the data from the results. So the evolution of science is rather slow and involves a lot of looking, a lot of observation, a lot of trying different things, different methods, experiments, if you will, to be able to come up with results that would prove or disprove your hypothesis and allow you to generate a theory. Okay? So usually what happens is somebody gets an idea, and then they try to test it out, and then everybody else comes along and tries to either disprove it or to reinforce or prove it. And that's essentially what happened in the early days when they started working with microbiology. With no sense of how life began, several people emerged, one being von Helmont. Von Helmont tested where life came from. So what did he do? He found soiled clothing, he found decaying food, cheese, wheat, and he's kind of spread these things around. And then he watched. And you know what happened? Mice showed up. So his theory was that he could make mice from these inanimate objects. It continued along a little bit, and flies would come to the decaying food, essentially lay eggs in the decaying food, and the next thing you knew, the eggs would hatch, and he would get maggots. Oops, too cheap. So he said that he was able to make mice and maggots from inanimate objects, which sounds hilarious to us, doesn't it? How stupid. I think you could do the same thing if you wanted to. Get some old dinner and, you know, some cheese and put it around, and you get mice. And pretty soon you get maggots too. So we could repeat that and prove that he was absolutely right. Well, that's not the way it worked. Because after von Helmont, a guy by the name of Reddy decided he would do his own experiments too. And essentially, he probably had a lot to contribute to the development of the experimental method. Because what did he do? He took a bunch of meat, put it on a dish, took a second dish with a bunch of meat, put it on a dish. This one was like, and this one was. So the experimental method means that you're using a number of experimental modes to be sure you're getting a result that is able to be interpreted in a general way. Well, what he said is, yes, I can get living things from non-living things, but only if they're exposed to air. So he said it's air that allows living things to develop. And I guess that's pretty logical. You know, he covered up stuff and he left stuff open, and before you know it, he had living things in the air, exposed materials, and the covered ones never developed maggots or mice or anything else. I like these things, I think they're really funny. And maybe over the weekend you want to set up something like this, it would be very popular around the house, right? Everybody would enjoy it. They actually, some people in the development of medicine, when they were trying to build hospitals, one of the ideas was they wanted to put a hospital in an area of the city where it had the least amount of filth. So you know what they did? They would go around hanging decaying meat from poles and watch and see how many of them attracted flies and disgusting things. And then they built the hospital.